for all x cannot equal positive or negative y, x over x plus y over x minus y equals what? Okay, so a lot of students get held up based off of this puppy right here. This is just saying x and y cannot equal each other. X and negative y cannot equal each other, because if that were true, then that would make this denominator equal 0. And you can never, ever, ever have 0 on the denominator. It spells no. You cannot do it. It creates something called an undefined vertical asymptote, which hopefully you know what that is. But anyway, they have to put that little caveat in there or the math does not work. So to do this problem, we can ignore the beginning. It's just saying that they can't undo each other on the denominator. But our job is to combine these two fractions. So if I have the fraction like 1/2 plus 1/3, hopefully you remember from long ago that in order to combine these fractions, you have to get a common denominator. So we actually take those two denominators and multiply them together. And what's missing on the left, we multiply the numerator and denominator by. And what's missing on the right, we multiply the numerator and the denominator by. So if you notice, the denominator says 3 times 2, the denominator says 2 times 3. This denominator says 3 times 2, this denominator says 2 times 3. So now all of these denominators match each other. That's the whole point in all of that. And now our numerator says 3 plus 2. And I am able to add 3 plus 2, and I'm able to multiply 2 times 3. And so I know that 1/2 plus 1/3 equals 5/6. Okay, what I did here in this step was just multiply by a funny looking 1. So the number 3 over 3, if I have 3 of something and I divide it into 3 groups, each group gets one thing. I am just multiplying by a funny looking 1. Okay, our 1 is going to get way more funny looking. So I have this denominator, x plus y, and I have this denominator, x minus y. Well, I'm going to create a fraction that has those denominators. So the blue one is x plus y, and the green one is x minus y. But guys, to get that common denominator, I need to take what is on the left and put it on the right fraction. And I need to take what is on the right's denominator and put it on the left fraction. So I'm going to show you that algebraically up here. So this green x minus y needs to go to the numerator and the denominator of the fraction on the left. X minus y, x minus y. I told you it's a very funny looking 1, but if I took x minus y and divided it by x minus y, it's just 1. So I am just changing the way it looks, but I'm not changing any of the value. So I have x minus y getting multiplied by x that was already there. Okay, I have a plus sign, and I already have a y in that question, but that y is going to get multiplied by what's missing on the right, which is an x plus y. So he's going to get multiplied by an x plus y. All right, so let your brain soak all of that in. Here's how I like about it, guys. If I took this fraction and I canceled out the green that matches, I would be left with the original question, x over x plus y. Same thing if I think about it on the right side. If I took this part right here and I canceled out what matched because it made a 1, I would be left with y over x minus y, which is what was on the right of the original question. So some of you are like, well, Miss Johnson, why did we even add all that extra stuff? Because now we can do the math. So I have a common denominator of x plus y, x minus y, and I can do the math on the numerator. Well, the first thing I see is that x is getting multiplied by x minus y, which would create x squared plus, oh, Miss Johnson, minus xy. And then I have plus xy plus y squared. Now I have no more parentheses on the numerator. That's good news. If you notice right here in the center, I have a negative xy and a positive xy. Those are actually going to undo each other and leave me with x squared plus y squared on the numerator. Well, I can go look at my answer choices. X squared plus y squared on the numerator would not be A, would not be B, would not be C. So I should be left with D or E. Now, we haven't quite finished the denominator yet, and so I kind of got a little bit ahead of myself. But usually on this complicated of a question, it's not going to cancel out with anything on the denominator. So I thought I was pretty safe to go ahead and do that. All right, the last part of this question, my denominator does not look like any of these answer choices. And some of you think that D does not have a denominator. Yes, it does. Every fraction has a denominator of at least 1. Okay, so on this problem, some of you probably have already thought forward a little bit. You could factor the denominator on E if you're thinking about the algebra that you know. This is called a difference of two squares. So x squared and y squared being subtracted is a difference of two squares. So I could even think about this without even multiplying it as x minus y, x plus y, and it matches what I have on the denominator. So I know the correct answer is E. Or you could work at it from the question forward and go ahead and multiply y times y, x times x gives me x squared, x times y gives me negative xy, positive xy, and then negative y squared. Again, those two in the middle will cancel, and we're left with x squared minus y squared on the denominator. So this correct answer is E. Now I just want to preface this. The difference of two squares is a very, very, very common thing on the ACT because it just throws in an extra level of difficulty. But if you guys have that memorized, then it will help you do a lot. It'll help you do with math problems a lot quicker. So this is, again, what's called the difference of two squares. Go Google it. See what you can figure out about the difference of two squares. It's really handy because these middle two terms will always cancel whenever we are working with a difference of two squares. And that's what makes it so fancy. All right, hopefully that was pretty straightforward. Common denominators have to happen when we are adding or subtracting fractions.